node voltage. So I did the current out of this branch was minus IS. Current out of this branch is Vx minus 0 over 1 R1. And then the current in this branch is Vx over R2 plus 1 over CS. This term by again the 2 milli S. So it turns into that term again, Vx over 2 milli S, 1K plus 1. So from here, I again combine the bottom. So we'll take this part over here. So in order to get a common denominator there, I have to multiply the one with the 1K by 2 milli S 1K plus 1. And then the 1K stays on that top. And then I need to multiply this one by 1K on the second term to get the common denominator of 1K times 2 milli S 1K plus 1. And so I plugged in the V of X here. So the 10 milli or 10 plus 15S over S times 10 to the minus 3. And then Vx is this portion here. And then it's divided by this. And so those end up canceling the top and the bottom component. And then the 1K times 10 to the minus 3 cancel each other out to give you 1. And you're left with the 10 plus 15S over S. And then I just multiplied the bottom part out. So it was 2S plus 1 plus 2S, which became 4S plus 1. From here, I needed to do partial fraction expansion. So A over S plus B over 4S plus 1. Note too, though, that in order to get it, well, from there, I just did for A, forgot to write that. I evaluate it at 0. So I plug in 0 and multiplied the VC by S. And so 10 plus 15 times 0, 4 times 0 plus 1 ends up being 10. And then B is solving that, I get S is equal to minus 0.25. So I plug in the minus 0.25, that gives me minus 25. And then the form though is A over S plus A. So I need to get this S plus A. And so I have to factor out the 4. So that becomes B over 4. Which gives me 10 over S plus a minus 6.25, which is minus 25 over 4 over S plus 0.25. And then I can match it to the table and convert it so that becomes 10 U of T minus 6.25 e to the minus 0.25 U of T. The conversion of the IS of T and the R1 into a Thevenin. And so that should yield the same result. So this becomes my simpler circuit between A and B. So my VTH is just going to be IS times 1K and RTH is 1K. So there's really no node, but you could call that VC and then do VC minus IS times 1K over 2K plus VC over 1 over 2 MS. My ground in there. You could do it that way. It will yield the same. Or you can just say VC here is going to be IS times 1K times 1 over 2 milli-S over 2K plus. This might be easier algebra, so let me just keep going since I'm here. So that yields the same equation. That one is much easier.